Okay, calculating limits. Let's just go with an easy function to start with. We're calculating f of 2, so f of 2 is simply 2 times 2 plus 7, which is 11. We can find the value of the function. The value of the function is 11, where x is 2. The graphical representation of that is if I were to graph y equals 2x plus 7, where x is 2, my y value will be 11. There's a graphical representation of that f of 2 and what my answer represents. Pretty basic, we all know that. Clearly, we can also get functions that define real-world situations such as temperature, distance, acceleration, etc., etc. So let's just say we've got a real equation here that needs to be solved so that we can solve global warming, and all we need to do to solve it is to work out f of 3. Well, that's going to be 3 squared minus 9 on 3 minus 3. The top doesn't really concern me too much, but this bottom, I can't divide by 0. So I've got a massive problem here, is that I can't solve global warming. Oh, okay, so let's find out what's happening. Let's use limit theory to find what's happening where x is about 3. So all we're going to do is play with numbers, really. Limit as x approaches 3, and we notice the top can be factorised, and nicely we can cancel those factors and get, hey, now we're not dividing by something by 0. We can actually set x equal to 3. What's 3 plus 3? 6. So we've found out that even though we can't set x equal to 3, if we could, the value of the function would be somewhere around 6. Well, it probably will be 6. But we can't do it by setting x equal to 3. It's probably about time for you to jump into Desmos and graph y equals x squared minus 9 divided by x minus 3. Go and do that now and come back to the video. Now that you're back, you will have found that the graph would be a straight line, x plus 3. So if I graphed that, I'm going to get that function there. That would be x squared minus 9 on x minus 3. Yes, even though it looks like a parabola, it's not. And clearly, where x equals 3, there's going to be a point. I didn't do that very well, did I? Over here, that would be the point 6. We found that out before. I don't know whether your graphing program will be good enough. But if you drilled in narrow enough, you would find that it's not a continuous graph. It is a discontinuous graph, and there's actually a hole in the graph at x equals 3. Because when the graphing program tries to set x equal to 3 and get a value for it, it can't get one. So there is definitely a hole in the graph. It's a discontinuous graph, which is why we couldn't at the beginning find f of 3, because you can't divide by 0. So limit theory is all about finding these holes in graphs and what they would be if we could get an answer. Clearly, this is high school. We're going to limit ourselves to quite simple limits. In later years, or specialist maths or university, limits will come in when you're thinking about setting x equal to infinity, dividing by 0, etc., etc. We don't need to get into that, but limit theory pops up at uni, and it's a barrel of laughs. Anyway, for you guys, you need to be able to calculate limits. and it will be to do with factorising the top, cancelling your factors, and then getting your answer. And this leads on to differential calculus, which we'll get to in the next lesson, and we need to divide by 0, and this is how we do it.